Okay, so welcome back. This is the fourth lecture for week 11. So as you know, in this week our focus is on air pollution issues. So we'll continue that discussion. So in this particular video, we'll talk about some air pollution models. When we say models, they're not exactly like a model, environmental model that we talk about. We'll talk about, say, in a scenario, if there is a you have for simple example, let's take example of a stack, a chimney. So you look at a coal based thermal power plant, or look at any industrial plant, and you see a chimney, and that from the chimney on the top we see a lot of smokes coming out, and that is smokes travels, and it travels in a different way depending on the time of the day, depending on the ambient air temperature, depending on the flow of air, how the air is moving and all that. So we'll discuss that aspect, what really happens. We'll try to look at some of the mathematics associated with that. We'll not go in too depth on that mathematical part, because that's, again, this is a intro course, it's an environmental science course as per the Honorable Supreme Court mandate of our in the country. So here the goal of this course is to sensitize you for the environmental issues, not to get into those nitty-gritty mathematical differential equations which many of you will get frightened with. Those of you who are interested in those aspects, there are other courses out there on the NPTEL platform as well, and you can always put questions on the discussion forum, and we will be more than happy to engage you on conversation there in more detail, and I can provide you some reading material also in detail if you desire. So you have to just put that request on the discussion forum, and we will do that. So in terms of what happens, say, if depending on the time depending on the ambient conditions, there are, if you have a air pollutant, if you have a partial of air, if we say like a partial of air, they will try to have upward movement. Usually partial of air, as you will see with it's lighter, and so it has a tendency to move upward. Of course, there will be like based on the gravitational pull and other stuff, there will always be a tendency to move it down, but there is during that when we have based on the wind pattern and all that, it's known as when you have unstable conditions, vertical movement of an air particle in the atmosphere is encouraged upward or downward depending on the condition. Unstable conditions most commonly develop on sunny days with low wind speed. So what happens on a sunny days, your wind, that upper layer of the wind gets warmer. So as the wind gets warmer, it tries to go up, and the colder air from the side tries to come in. So we have a circulation of air happening, where hotter air tends to go up, and the lighter air from the sides are coming in to take its place. So on a sunny day with low wind speeds, the land surface will quickly absorb heat and transfer some heat to the surface air layer. This air warms, becomes less dense, thus more buoyant than the surrounding air, so it rises vertically. So we have a vertical lift of the air getting, and when there is a vertical lift of the air from the side, other airs will come, the colder air will come and try to take its space. So that's what happens in an unstable condition. Vertical movement of an air particle does happen. So as you can see, it's based on at the elevation, based on as the temperature goes up, we have environmental lapse layer rate. So we will explain all of these, what is dry adiabatic temperature difference and all that. You will see this picture again summing up in other slides too. So during a stable, that was an unstable condition. During a stable condition, vertical movement of an air parcel is discouraged. So it's kind of stay still. Under very stable condition, a cooler layer of an air near the land surface is capped by an upper warmer air layer. So you have a cooler layer, on top you have a warmer layer. This condition is called an inversion. So you have a cooler layer, and then on top you have a cooler layer of air near the land surface is capped by an upper warmer layer. So this is called inversion, and prevents vertical motion of an air particle. So it doesn't let air to go up. So it's that's happened. So, neutral stability occurs when the environmental lapse rate is same as the dry adiabatic lapse rate. So, what is the vertical movement of air is neither encouraged nor supported under these conditions. So, neutral stability typically occurs on a windy day when cloud cover prevents a strong heating or cooling of the land. So, you will have neutral stability where either things will not go up or not even go down. So, same as so your environmental lapse rate, which was the first condition that we talked about, where the environmental lapse rate it's an unstable condition where the vertical movement of air parcel is encouraged. There this shows the environmental lapse rate. In the second, where we have a vertical movement is discouraged based on the dry adiabatic lapse rate. When those are both are equal, environmental lapse rate as well as the dry adiabatic lapse rate. So, you are having a situation in which vertical movement of air is neither encouraged nor supported under these conditions. So, under neutral stability typically occurs on a windy day when cloud cover prevents a strong heating or cooling. So, temperature inversion occurs when a warmer layer of air resides above a cooler surface layer. Areas that are prone to inversion occurs where large population of human resides. These areas includes coastal zones, valleys, locations near mountains. So, you have a inversion layer. So, we have a warmer layer of air resides above the cooler surface layer. So, here you have temperature environmental lapse rate in this particular range, and then you have a dry temperature inversion, then and of course, the dry adiabatic. Initially, it is kind of at a lower elevation, it is the same, but then we have the dry adiabatic lapse rate kind of going the other way. So, looping occurs in highly unstable areas conditions. A rapid turnover of air causes turbulence. Looping plumes are usually preferable for dispensation of air pollutants and usually result in low exposure to low pollutant concentration. How there could be episodes of exposure of high concentration, where the plume loops downwards to ground level. So, you have a looping happening where the loop is actually coming back to the ground and creating exposure. Fanning is where it is a very stable. Looping is what you see over here, that is your looping conditions. As you can see, the smoke kind of having this kind of pattern where things can go towards the surface and can have more exposure. Fanning is more as you can see, this is your fanning, very stable. Things are just moving horizontal like in a nice and smooth. Inversion prevents vertical movement motion of plume, but horizontal motion of the plume is not prevented. So, it does happen downwind, you will have the horizontal movement. Coning occurs under neutral condition where atmosphere conditions are slightly stable. So, here you are having coning. So, basically the plume that is coming out becoming like a cone, and then it can have a higher exposure as well, because things will come towards the surface too. Then we have lofting, which is release of air pollutants occur just above the inversion. The air above the inversion is unstable, which encourages vertical mixing above the inversion layer. So, this is actually good. In this case, ground level acceptors are fortunate, the stack height is above the elevation of the inversion. So, since the stack height is much higher, we see things happening on this region. So, if we have even the houses and other things in this, there is no exposure to population in this particular area. So, it becomes actually good. So, in general, fumigation, which kind of it looks like air pollutants are released just below an inversion layer. Air below the plume in this case is unstable. So, ground level receptors can be exposed to high level of air pollutants. So, that's the fumigation level. So, there are between the water and land, as we know, the sea bridge and the land bridge, because of the hot, if it is too much heated up, our surface above the land gets heated up faster. So, air above the land will go up, and then we will have a sea breeze coming in, and in the other way in the night when the water gets cool, the surface gets cooler faster than the water. So, it gets colder. So, the water if from on the top of water, again the hot air is there, they go up, and the cool air from the land goes to the sea. So, that is your sea breeze and the land breeze concept. So, based on these different coning, fanning, lofting, all these different fumigation, they will all we can explain them using these mathematical formulations, which is the fundamentals of the dispersion modeling. So, here C concentration can be expressed in this equation. We are not going to ask you to memorize this equation. We are not going to kind of I just wanted to show you that these kind of modeling activity needs to be done to understand air pollution issues. So, say tomorrow you become an IAS officer or whatever, you are sitting on any decision making chair, and then you are looking at some air related reports. You should understand that when you see these kind of data in front of you, you should try to understand the complexity of generation of those data, and also how detailed they needs to be, so that you can ask some counter question. That's the whole purpose of. I don't want to scare you by showing these differential equations. Some of you might be thinking that, oh my God, what is it? But don't worry, it's just like it's a those of you who have the engineering and science background, you should be fine. Others may be a little bit having a problem. So, here the C is your concentration, and x, y, z, because we are looking at the 3 coordinates. So, it would be x is downward distance, y is crosswind, z is the vertical, and h is the effective release height above the ground surface, so from where things got released from the chimney. S is the continuous pollution emission rate, like a sigma y and sigma z dispersion coefficients in y and z direction. So, it is based on that you just get the concentration in 3D. Now, you can make it here, x, y, and z has been mentioned here as well, that how they are. First term is provides concentration directly at the concentration of the plume. Second term adjusts as you move in the sideways, because as the concentration move. So, you have this this is our chimney. From the chimney we have a smoke going out. So, we are looking at x direction, y direction, and also z direction, because we are looking at 3D. So, the first term is actually as soon as provide concentration directly at the center line. So, there is a center line of the plume. Plume is say if this is my chimney and things are coming out and something like this. So, there is a center line. So, this center line, it will be known as the center line of the plume, and then we have the extremes. So, second term adjusts the concentration as you move sideways in the y direction. The third term adjusts in the vertical z direction. So, you have so based on so you can, because there is a dispersion happening in other 2 directions, like it's a movement in essentially 3 direction, x, y, and z. So, you have what is happening at the center of the plume. With respect to that, also we have the dispersion happening of the air pollutant in different directions. So, those is taken into factor in this particular equation. So, here a V, and then we will have the V exit velocity of the stack gas. So, here this is the h is the height of the stack, delta h is what is the center line of from this height of the stack to the center line of the plume. H, capital H is the total of h plus delta h, and then this is our the plume coming out, delta h is the plume rise. So, if here we can put the delta h as in the picture of V d upon mu. So, where V is the exit velocity, D is the inner diameter of the stack, Ts is the exit temperature, Ta is the ambient air temperature, and P is the ambient pressure. So, based on that we can write down what would be the plume height. So, delta H we can find that out. So, there are this is the most common model used. We are most times concerned with the concentration of an air pollutant at the ground level, because that is where the exposure of human and crop would take place. So, so we here the focus is on it should be take place, not tail place. So, it's a this is where so we have this is the equation for Gaussian plume model, which we try to predict what will be the concentration at the ground level from the stack emissions. So, that is because that is where the exposure will take place. So, this is one based a manufacturing process emits this much pollutant SO2 every minute. The stack height is this, 0 plume rise, wind velocity is 3 meters per second, horizontal dispersion coefficient delta y is 25, vertical is at 15. What is the concentration of air pollutants? 0.5 kilometer downwind of the release along the center line. So, we have to ask us to estimate the ground level concentration. So, we both the estimations are at ground level. So, we will use the following equation. So, this should be so So, we will use the following equation. So, it's this is the equation that we also looked at the previous slide. So, you can have, as you saw in the previous slide, this is the equation from the Gaussian plume model. So, we can use the same equations over here and bring it to here, and then we put 500 our x, y and z is 0 0. So, put those numbers, we put other two as 0. So, we get concentration to be 6.9 micrograms per meter cube. So, those are is there to protect. So, that's in terms of the air pollution. These are kind of what we wanted to look at, and so that's next we will be also looking at in this particular week. We were also planning to have a very quick discussion, although the topic in the initial I mentioned only air pollution, but the goal is also to have a very quick look at noise and soil and those kind of pollutions too, because that's again also some of those issues associated with our environment. So, in terms of noise pollution, so let us look at the noise pollution part. It's we are trying to protect the healthy life. So, there is a noise pollution is becoming a problem. It's an issue of a lot of issue in terms of noise. So, we will talk about that noise pollution as well in this particular week. So, before we get to that, we will try to talk about in terms of air pollution issues, how to control them. So, when we have these air pollutants, what is the best way to control it? So, here we have there are in terms of air pollutant, one of the thing we use is adsorption process, allows for gaseous pollutants like VOCs and SOs to be transferred from air to solid absorbent. So, what we are doing is essentially you have a filter. So, this is your carbon bed, that is the filter. Your carbon bed is actually a filter here. So, you pass the air through it, and then as the air passes through, VOCs and SO2 will be transferred from air to the solid absorbent. So, it will come into the solid absorbent, and so similar thing was also we discussed about it in the earlier video about the water. So, it's in the week I think it's week 8, it should not be chapter 8, but week 8. So, where we in the week 8 we also looked at the treatment of water. So, similarly we can have so this should be rather than chapter, we should call it week. So, that is similar approach can be looked into in terms of for air pollution, where the horizontal bed absorber shown on the right is commonly used for larger flow rates. So, we use this for larger flow rates, we try to do this cleaning of. So, essentially what we are doing is the air pollutant is getting transferred from the air phase to the solid phase. Bag house is used in many places for particulate matter to be filtered by set of fabric filter bags. Bags are periodically shaken to remove the particulate matter into underlying hopper where it is collected. So, we have so as you can see, you will have gas inlet going in, and then the gas outlet is from the top. So, this is the inlet, the outlet is over here, this is the bag house, in which as the gas passes through, the particulate matter will be captured, and then from time to time particulate matter will be taken out through this after shaking it in those from those bags. It will be like shaken out, and it becomes what is known as the fly ash as from the air pollution control system. Biofilter again degrades gaseous pollutants, VOCs and odors by use of microorganisms that resides on the filter media. Filter media could be something as a lava rock or a mixture of compost and wood chips. Air is typically passed up through the bed. Periodically moisture may be added. Why moisture? Because whenever you are using microorganisms, whenever you like a bio based stuff, you need to have certain moisture, otherwise the bacteria does not like it. So, you have air with VOCs and odor getting in there. So, this is then here we have some biochemical reactions, packing bed supporting biofilm, biochemical reaction will take place, treated air is gone out. We add periodic water, then water with oxidation product is also taken out, and then so that you can treat this water and recycle it back as well. So that's cyclone again is for particulate pollutants. with the gas and removed by centrifugal force because the particle have more momentum and cannot turn with the gas. The air is moving in a helical pattern. So, you put let the air pass through a helical pattern, particles that impact the cyclone outer wall then fall by gravity into Hooper where they can be collected. So, we are just taking the advantage that gas and the particles have more momentum and cannot turn with the gas. So, based on removed by centrifugal force, we remove those in that cyclone is used for that. ESPs, electrostatic precipitator, which is particulate matter is first charged by applying a high voltage, now which produces ions that attach to the particles. The charged particles then forced onto collection plates. Rappers use impulse or vibrating methods to remove the particles from the collection plate. So, they place into the hooper where they can be removed. So, the flue gas is in. So, here it's a very popular this ESPs, electrostatic precipitators are very popular, and it has to be these days it's a kind of common in all the air pollution control system. You will see ESPs, which is becoming very common. So, we have the flue gas coming in, and then it goes the clean gas comes out from here. So, in between we have this electrostatic precipitators, which is what happens is particulate matter, it gets charged by applying high voltage, and which produces ion that attach to the particles. The charged particle pass through these collection plates. So, the rappers use impulse or vibrating method to remove the particles. So that is how it is done to remove it. Packed bed absorption is scrubber pollutants are transferred from air to the liquid. So, here we have K performance indicator is how well equilibrium between the gaseous and the aqueous phase favors the liquid phase. So, also important is the rate at which the pollutant transfer from air to liquid phase. So, you have west air stream getting into those, then treated air is coming out, we have the scrubber liquid coming into passing through the media, then we have the liquid waste coming out at the bottom. So, that is what happens in terms of in this in our packed bed adsorption. Thermal oxidizer, where VOC is oxidized through high temperature combustion. System consists of burner, reaction chamber. Removal is better with greater temperature, turbulence, gas residence time. So, essentially you are burning all these organics and making it cleaner. Venturi scrubbers is also used sometimes where particulate matter, other pollutants or such as SO2, HCl can be removed together by impaction of airborne pollutants on water droplets. A water spray can be added by several methods, including injection into following gas. So, that is the gas inlet. You have a spray header, liquid inlet. So, it movable we have a movable throat dampers, the gas outlet is there as well. So, when it passes through that SO2 HCl can be removed by impaction of airborne pollutants on water droplets. So, water spray added by several methods, including injection through the flowing gas. So, that is how it is taken out. So, this is different ways in which air pollutants can be removed and are being removed. You go to any plant, you will find these kind of different combinations of these stuff there. Baghouse, ESPs, those are very common, especially the first few ones that we looked into, like a filter. It's looking at the baghouse, looking at biofilm is again very common. Biofilm is used, cyclone particulate pollutants, ESPs. So, these are very popular. And the others are also used. It is not that others are not used, but in terms of whenever you go and visit a plant which has a air pollution system as well, you will find baghouse, those ESPs and all that. So, being said that, so those are the ones how those pollutants are removed. In one of the previous videos, we did look at some of these indoor air pollutant sources as well. So, it was slightly in a different context. So, it was kind of air pollutants in general, like not indoor or outdoor. Here there is a table has been prepared to look at the indoor air pollutants. So, in terms of indoor air, which is very important. So, if you think about that, mostly other than 8 hours of our work day, and although I am saying 8 hours of work day, but most in in the many job setting today, it's 8 hours is sometimes 10 hours, sometimes 12 hours. So, and again with the travel time as well in big cities. So, but still it's the house, it's the indoor which where we spend most of our life. So, whether in our house or other people's house, so it's a that's the air pollutants within the inside the house is what can impact more, and it will impact more to children, older people who spend more time at home. They are the vulnerable population, like older parents, then children's, they spend more time in indoor setting. So that's it becomes an issue. So, and it could be, when we say indoor, it could be also be indoor at your workplace. So it's so all those if you look at these indoor air pollutants, let's look at some of the sources and examples. So combustion, whenever there is a combustion, we'll have burning oil, gas, kerosene, coal, wood, tobacco products. They can release fine particulate matter, carbon monoxide, hazardous air pollutants into the indoor environment. So outdoor sources, we have pesticides, and outdoor air pollutants can enter the indoor environment as well through open windows, cracks, ventilation intake, from dust carried into buildings or sews. Radon can enter through buildings foundation. So radon is a big deal in many parts of the world. In fact, in Tennessee, when I was living in East Tennessee, I was there was a drive going on where the government wanted each homeowners to measure radon in their house. So you can even get those radon kit. You can request for those radon kit, and I think there was a pay, or it may be free. I'm not sure right now. You can get those radon kit to your home, and you do the sampling. There was a clear instruction on how to do the sampling, and then you send it back to a lab detail, and then in the lab it will get analyzed, which will be free for, like a whole homeowner doesn't have to pay for it, and that results will be shared with the homeowners once it's available. So if there is a problem of radon, they also try to tell how to actually take care of that, how to make sure that you are not exposed of it too much. So building material and household furnishing, asbestos, leads are found in building insulation. VOCs are also there, flame retardants, those becomes an issue. Household product, VOCs, hazardous air pollutants, fragrance emitted from common household cleaners, maintenance products, personal care products, printer ink, biological pollutants such as mold, that's again a big problem, that's a dampens and water leaks. Household inhabit pests and other pets, people, rodents, insects, plants can all set off gas, volatile particle, allergens, some gases such as vacuum with a poor quality filter also resuspend deposited particle into the air. Around 3 billion people world depend on burning solid fuel, kerosene, so which can have serious negative health impact. Women, children primarily in low income are more at risk, switching to cleaner fuels will help. So based on that, there are these are the different air pollutants, and then also we also then issues associated with those air pollutants, like how they get into what are the sources. So now we will get into the sustainable development goal side. So what I would do is let's stop here at this particular video, and then we'll start talking about the sustainable development goals, and then we looked at very briefly about the noise and soil pollution as well in the next video. So thank you very much. So we finished the 4th video of week 11. So now one more video in this week, and then we'll have the last week, which will have a lot of case studies. So again, keep active your give us questions on discussion forum. We'll be happy to answer, and I hope you're enjoying the course so far. Thank you.